Evening, everyone. Welcome back to another live stream. I was live last night, and we were playing around with some electronics, and I got a bit stuck 'cause I couldn't find the Arduino that I ordered. But I am very pleased to tell you. Let's have a look. I'm very pleased to tell you that here on my desk right now, I have got the Arduino that came in the post. Now I might get onto this today, or I might not quite get. There's a few other things I've got to do first, because I've also had some other things arrive in the post today. But I'm a bit more able to do a few more things. Anyway, but here we got it's an unopened Arduino. It's not a sort of an actual Arduino. It's a sort of third party brand. But yeah, I'm looking forward to having a go with that. So I might try and plug this in and see if I can sort of set the IDE up and connect it to the computer and put some software on it. That'd be a good start. Hello, Norway Station. There we go. Hello again. Right. Anyway, I've got the Arduino. That's a good start. I've got a few other things came in the post. Got here a nice big box of goodies. But in particular, I got these, which are some motor drivers. And I also got these, which is a smaller packet of motor drivers. So I'm interested in building my own accessory decoders for the Tortoise point motor. So to do that, I need some sort of motor driver, and well, here's two sorts. I think I mentioned this yesterday. This one, the smaller one, the cheaper one, cheap is good. But the cheaper one, it can control a voltage up to 10 volts. Well, I haven't got 10 volts on the layout. I've got 5 volts or 12 volts. And 5 volts takes 6 seconds to turn this, turn over this Tortoise point motor, which is too long. So I want to see just time how long it takes for 12 volts and see what I can do with 12 volts. Maybe blow one of these up trying to use 12 volts, or maybe it'll work with 12 volts. Who knows? Probably not. Anyway, we'll see. So that's that. Or I got these, and these are a bit bigger. It's obviously a bigger packet. So I'll open these in a minute, and I think these will work, but we'll see. Anyway, so that's all to come. Let me just put those there. So before I get on to that, it's a bit bigger. Before I get on to that, I've got a few other things to do. Let me just put the Arduino. Let me just put it here where it's tempting, because it's tempting just to play with it. There's a few other things I need to do. So I mentioned I want to have a go with 12 volts driving this. So the first thing I need is a 12 volt power supply. Now, if you were with me yesterday, you'll remember I got a 5 volt power supply and just cut the end off. And as luck would have it, is it this one? Here we go. I've got a 12 volt power supply. So I can just do the same thing again with this. And at least then I'll have two good supply voltages to play with. Oh, do you know what? I've left the tools next door. Let me just go and get some snips and so. Sorry, it was a bit of a lack of planning. Oh, hello, Steel Parallel Lines here again. Maybe you should take a look at a much cheaper idea using an Arduino board and some servos as point motors. So this is to say, don't use the Tortoise point motor, use the servo. And I could do that, and actually I'd be a lot happier doing that once I've sort of worked out how to do some of the other components, and the Arduinos, use an Arduino and so on. As it happens, I got a load of these. I bought 24, and I've probably put, I don't know how many I've put on the layout actually. 16, 14, something like that. Anyway, I've still got a load of these left, so I'm certainly going to use these up. I did think I might switch to cobalt, from DCC Concepts, just because they exist, and they're local, they're not American, so I don't have to do that. Or use, what's it, the MTB point motors. What are MTB point motors? I want slow action point motors that are quiet. But tell me about MTB, Jeff. Anyway, but either way, I want to sort of be able to use Arduinos to build my own control circuits and so on. Let me just go and get some wire snips and strippers, otherwise I won't make much progress. Probably a good moment just to go over some essential tools for playing with some electrical stuff. So here I've got some cutters. This is for cutting wire, so that's good. Here I've got some strippers. These are for stripping wire. These are probably the cheapest strippers you can get in the world. There's probably much better strippers you can get. Anyway, I'll make them work. Some needle nose pliers just for gripping things. And there you go, Stanley knife for cutting things. And here I've got these crimps. Now these are crimps that I use with the dew point connectors. Here's my dew point connector set. I'm sure I'll get around to using that in a moment. But I like that because it's just good for making things sort of connect and so on. You control, so still parallel lines, you control the Arduino and the S21 start through iTrain. Yeah, I use iTrain as well. Same setup as I'll have. Well, I don't use sorry, it's not an S21, it's Z21, isn't it? I don't use a Z21. I've got a Digitrax, command station, but you know, same thing. The point is, it's got a LocoNet connection, and actually, LocoNet's what I want to hook my Arduinos up to LocoNet and do fancy stuff through that. But we'll get onto that. I'm touching this because this is a LocoNet interface board that I need to get on to play around with. Jeff says yes, they are slow action point motors. I used the DCC concepts in the past, but now you're using the MTB, MP1 and MP5. Really good. Right, I've heard Charlie Chadwick talk about MP1 and MP5. So, what do they cost and what's good about them? Let me know. Anyway, I'm going to crack on and start playing around with this 12-volt supply. So again, I'm just going to cut off the barrel plug. Do you know what? I should have checked the voltage before I do that. Anyway, I think it's the same barrel plug connector. So I've got two of those now, which is handy. Never mind, I can check the voltage in a moment. I've got my multimeter here. So if I just separate the wires. Now on the last one I played around with, the wire with the white stripe was the positive, I think. It's less hard to tell. It's harder to tell on this one. Oh, there's a grey stripy line on it. I can't quite see it. You might be able to. Anyway, never mind that. Let's just strip it off and get on. I normally set these strippers to gauge 22. Yeah, see, gauge 20 is not going to strip it. Gauge 22. I think that's American wire gauge. When I say gauge 22, so obviously American wire gauge is an American standard. No kidding. Right. There we go. So I've got 2 sets of wires. Just twist them a bit. Right, let me put some power on this and check the voltage. Oh. I don't know if you can see. Do you need to see? You're plugging it in. There we go. So I've plugged that in. Out with the multimeter. Same. Yeah, Charlie was using them because he couldn't fit anything else. Yeah, no, that was a thing. The MTB, some nice and small with a much lower current pull than DCC Concepts and Tortoise. Right, okay. But it's the same thing. What voltage do you need to give these MTB point motors then? Right, let's just see what we've got here. So I'm hoping it's 12 volts, but you never know. Look at that, it's 16. Oh, for goodness sake. Right, I wanted a more regulated supply than that. I don't really want 16 volts. Which way is positive? Oh, this is really annoying me. Oh, you can't see. You can't see why I'm ticked off. There you go. So if I put the positive on there, negative on there, you'll see it's reading 16.3 volts. This is supposed to be a regulated 12 volt supply. AC adapter, it says. Secondary, 12 volts, 1 amp. But it's not, is it? Right, well that's annoying. It's what I've got. So let's crack on. Now I think we discovered yesterday that we couldn't really get dew point connectors on these because there's a slightly larger bit of insulation. So I will solder on some extension wires and I'll use that. There it is. Right. I think I'm a bit more organised today. I think yesterday I went online on a bit of a whim, really, a bit of an impulse. But using the supply you have, what is the current it supplies? So the Jeff, if you're asking about this wall wart, it says it can provide 1,000 milliamps, but we'll see. I think is the answer. Who knows what it can actually supply? Right, I'm on my desk. The trouble is, if I get disorganised, I'm going to end up knocking the tripod that that you're on, and then everything's going to go to hell in a handbag. This is my soldering bag. I have the soldering iron. I think some solder. I've got a solution for cleaning my soldering iron, which is it's a pesto pot. But in the pesto pot, I keep a brass sponge, and I've packed it out with newspaper to keep the brass sponge to the top. So I can put that there and just dip the soldering iron in when I fancy. Really into a wet sponge. It's a bit of an effort, I find. But I probably should use it. Right. While the soldering iron's getting hot, we will strip these wires somehow. So gauge 22 is perfect for this. So what are the rest of you doing this evening then? was just saying, using the supply you have, what's the current supplies? Yeah, no, we talked about that. What are you guys working on tonight then? Apart from just sitting around. Perhaps I should just tin both ends. I think I'll do that. Actually work quite nicely. But I'm now supposed to be able to come up with some sort of magical way of it's not quite hot enough. I'm supposed to be able to come up with some magical way of sort of twisting the wires together, splicing them together. I've never really found a good way of doing it, especially if I've got one solid core wire and one braided wire. I never quite know how that's going to work. Hello everyone, it's Heritage Line. How you doing? It's good to see sort of familiar faces in. Oh, goodness sake, why am I so rubbish at soldering? Did I get a chance to have a look at the website? I didn't actually, I'm sorry. I went straight to bed because I was so tired and I've been busy working all day. But it sounded interesting actually. Tell me a bit more about what I'm going to learn when I have a look. I got the impression, I didn't try to remember what you said. I got the impression it was going to teach me how to sort of use an Arduino to make like a LocoNet monitor. I'm hoping that's what it's about, because that like you say, that would be a useful first step. Good, thanks. Today I feel like I haven't been online in ages. That's probably true actually, for which I apologise. Why did I get a spark off that? Did I get a spark off that because there was I just shorted these wires out. It's not plugged in, but I suppose I got a shock off it because the capacitors in the power supply were charged up. What fun. What fun. Right. There we go. I'm getting a bit of solder on these things now. That's what I'm going to do is just trim off the excess. Tony! I think that's what I like about hosting live streams, is when people watch and and enjoy greeting each other. Do you guys watch Jenny Kirk? Because I know she always does a live stream on a Monday evening, and I'm not always there, but sometimes I am. But it's just a good place to sort of ask ask general questions of like a large group of people. Often there's someone who's doing the same thing you're doing. Just ask about it. Who knows how to do whatever? Someone normally says, yeah, that's me. Right. Let's see if I can make some sense of this. It will show me how to make a DCC interface between the Arduino and the DCC. Ah, right. So is that it'll show me how to make a DCC command station? That website. Because like I said, I don't need a command station. I'm sure I'll learn a lot of interesting stuff. But I don't need a command station. But I do want to use the Arduino to do some other things. Didn't tin this end. Lost a pin on the 08 wheel set. Ended up buying another wheel set. Oh no. That is frustrating. You sort of end up sieving your Hoover bag trying to get a tiny part. I've got to say that, and that's like an N-gauge thing. Is it? I mean, I know in 00 things are small, but not really. I'm always amused, like these 00 engines models, people sort of pick them up in their hands, whereas N-gauge models, you sort of pick them up in your fingers. That's the key difference. Why am I struggling with soldering? It's not a command station. I'm going to just have to go and look at this website and then find out what you're talking about. So what does it connect to? Does it connect to the Arduino to the DCC bus? Or does it connect the Arduino to like a command bus of some sort? You're probably telling me it connects to the DCC bus, which is obviously one of the steps I need if I'm going to, for an accessories controller, decoder. Oh, that's badly soldered. That thing. Obviously, an accessory decoder, I need to be able to God, I wish I wasn't doing this live. An accessory decoder, yeah, I got to be able to decode the DCC signal on the DCC bus and then do something with it. But I know there's examples of how to do that, so I'm not worried. It wasn't. There was someone here last night who was saying that trying to do feedbacks, of your point position to iTrain didn't work. But I did a bit of Googling. I've seen other people who saying they've made it work and they've done it. Joe's asking, what am I going to do with the Arduino? Well, there's lots of things I want to do with it, but I want to use it to make my own point motor decoders, because I was using DCC Concepts, but they seem to stop manufacturing the one that I was using, so I'm not very impressed with that. And I want to do my own block detection using the Arduino, and I was using, God, struggling with this. I was using DigiKey's device to do that, but DigiKey's have gone out of business. There seems to be a bit of a pattern, really, which is you sort of commit to a particular manufacturer or a particular model, as in product, and then for some reason it becomes unavailable, which is really annoying. There we go, that's sort of soldered on. What a mess. What a mess that was. Right. Connects the DCC bus. Yeah, that's what I thought. Well, I'll have a look at that video, because that'll be handy, because that's obviously, that's a very necessary step. And so presumably I could use that to then provide a trace of what's on the DCC bus, which will be handy. I mean, I think there's also using it to provide a trace of what's on the LocoNet bus. That's another step. So yes, I got this for doing LocoNet, and that interface, and I suppose the other bit is an interface to DCC, and then I'll have all the bits I need. Right, I think this time I've got a lighter in the room. Okay. Right. Ta-da! Right. It's not pretty, but it's done, so that's a good thing. Let me just put another bit of heat shrink on. I put a slightly fatter bit over both wires, and then it'll stop them stripping apart. Where the... Oh, for goodness. Oh, there we go. I can never find anything. DigiKeys has been... Yeah. So what is Yamaha? I mean, I looked into it, and I saw it was basically the guy who did all the clever guy who designed all the products at DigiKeys, now involved in what are we calling it? Yamark. But I'm not sure sort of what his focus is going to be. You know, and what products he's going to come up with first, and so on. So, a bit worried, and the price as well is a bit more than I got used to. Let's put it that way. Right. So I've got red and white, red and black. I think I've put the red and black the right way around, but we'll find out in a minute. just trim those the same length, and then take a bit off each one. I don't need the soldering iron anymore, so I'll turn it off. Otherwise I'm going to end up burning myself on it by mistake. Right, I'll strip these off, put 2-point connectors on the end. Now with the last night I put female connectors on, which obviously is sensible because it's a power supply. However, it didn't work very well for connecting it to the breadboard. So what I'm going to do today is do it the other way around. Let me just check. I've put the red and white the right way, red and black the right way around. Probably haven't. I'm like, oh dear. Right. 2. It's not giving me a good signal. Why is it not? Oh, it's on AC. What a muppet. Right. Measuring voltage DC. There you go. 16.5. Should be 12. It's a 16.5, and it was the right way around, I think. So, yeah. Okay. So I got my positives on red, so that's a good start. Right, 2-point connectors. So I'm going to put male connectors on here, so I can get that into the breadboard. I know this is all a bit boring and dull, but it's all necessary. See, it's all part of building up the infrastructure of what I'm doing. Once I've got a reliable power supply from a breadboard, then that will make life easier. So again, I'll show you how to do this. I take this with the open side, you know, the spiky bits pointing in this direction, and hook it in, pull it towards me, close it up to grip it. Now I'll turn it around the other way so I can see what I'm doing. Shove the wire in from this end until I can see it poking out the other side, and give it a squeeze. There we go. That is a good connection. I figured this out actually. It takes a while, but just seriously, you know, the video I made about me learning or trying to figure out how to do this is such a joke. Complete disaster. Right. It's always harder to film yourself doing something than just doing it. That's on nicely there as well, I think. So that's good. Right. And then if I take a 2-up connector, I can put them in side by side, and then that will make a nice connection to the breadboard, and it'll also stop, if I put both these in, it'll stop them shorting each other out, which is obviously very necessary. There we go. Put the other one in too, and I just need to gently grip it, pull it through. Right, that's discharging the capacitors again. Did you see that spark? Dear oh dear. Outage line I would imagine they're the same. Why reinvent the same wheel? Oh, you're talking about the yeah, Mark. Yeah, no, I know what you mean. I know what you mean, but I just get the impression he had like better ideas, you know, whatever the next model was going to be, the next version of everything. So instead of just creating the old one, he's sort of making a better one, and I'm sure it's great. But it may not be exactly the same thing. He may need to, you know, and where does he? I think the issue is sort of where does he start in the range with the range of products. Right, it's good to see if I can get a bit of heat shrink over here. There we go. Almost. Come on. I like to do this if I can. It makes the whole thing a lot neater. Get that. Can't get it on. It's a bit of a waste, isn't it? Very nice. So that'll just tidy it up. Where's my lighter gone? There we go. So do you all use DigiKey stuff? There we go. So that's all nicely put together. So what I can do is let's just plug this in. So maybe I could have 12 volts at the top and 5 volts at the bottom. Anyway, let me plug that in for now. Set it right here. So this little voltage divider circuit that needs to go in there. Right, so I should have 12 volts across the bottom. I just put that bridge in. I'll come back and sort out the 5 volt later. Okay. Right. So I can just check that I've got 12 volts, 16 volts as it actually is. Maybe I get myself a little voltage regulator just to sort that out. Oh. Okay. You're manual, but you're interested in looking at automation in the future. Right. I imagine it's quite hard to automate an existing layout though, because you've got to put all the blocks in. But you could block it up first and just connect them all together. I'm going to keep throwing bits of wire on the floor. Yeah, you could put in the, you know, isolate all the joints and so on, but just connect all the wiring together and then put the block detection in later when you're ready. So what Yammer, how are we pronouncing it? Is it Yamark? What Yamark products are available at the moment? Do we know? Right. So let's just make sure this power supply is working. See that? So I'm hoping for 16.5 volts. And I've got 16.5. You can't see it, can you? Why can't you see it? Actually, it's too far that way. See that though, can't you? Right. 16.5. That's your plan. Block it all up first and connect together. Yeah, well, you're a wiser man than me, Tony. I think you sort of figured it all out. So I'm not quite so smart. There you go. 16.75. So that's nice and clean. Right. Is this thing magnetic? Who knows? So that's a good start. Now what I'm going to do is, using my crocodile clips, click button to there. Where's the other one? Where's the red crocodile clip? I want to see how driving this Tortoise point motor works. Somehow I managed to lose my red crocodile clip connector. Oh. Right. So I will. Where can you can see that? That's good. Actually, you can see that. That's good. So let's see if this works. Okay, that doesn't work, but maybe it's the wrong way around. So we'll try that again. Yeah, that it does move it, but it certainly sort of has a bit of oomph to it. Now this is 16. This is 16 volts, isn't it? Wow, look at that. It goes charging across. All right, but I don't think we're breaking it. Does anyone know what the sort of rating of these Tortoise point motors is? Don't know. Anyway, so that's good. Okay. So I can drive this with 16 volts. So that's a good thing. What I might try and do is see how much current it draws when it's going. So we'll put the ammeter on. How's this going to work? This one over to there. That one goes there. Can't quite see it, can you? So that's ground. And then if we put this on here, so that is pulling 1 milliamp. We go the other way. 1 milliamp. Why is that not moving? Red goes into there, goes into there. Help me out. Why doesn't this work? Google search result. The power supply need not be filtered. Each tortoise will draw 15-16 milliamps at stall. So 30 compared by a single. If you're using 16 volts for the tortoise, will you be running another bus for the point motors? Well, I think this is the point. I got to work out. I mean, I'm not using 16 volts for the tortoise point motor. I want to use 12. But the point is, this 12 volt adapter, which I'm only using to play around with, is actually knocking out 16 volts, which I'd rather it's knocking out 12. But that's what I've got, so that's the end of it. Okay. Oh, is this measuring? Oh no, it's measuring DC or AC, I think. Anyway. Oh, damn it. I hate to say it, I don't quite know how to use this. Yeah. Well, I think really what I've concluded is all makes sense now. Yeah. What I've concluded is that I don't know how to use my multimeter to measure current. I think that's the bottom line. I'm just a bit thick, so we'll leave that. Right. Let's get all this out of the way, and we'll start doing something different. So, I got something in the post today, which was some of the things in this box. I got myself 2 different types of motor driver. I got a big bag, there's 5 in here. I got a small bag, there's 5 in here. So let's have a look at one of each and see what we got. So that's a big one. and this is a small one. So motor driver, from what I can work out, is basically an 8-bridge circuit. An 8-bridge circuit is some transistors arranged in a sort of H shape. So you end up with yeah, I had to draw it, but basically it's a bit like a full bridge rectifier. Depending on which transistors you turn on, it either sends a current through the load in one direction or the other. That's the bottom line. And so you can use a small signal current to drive a much larger current through, and even larger voltage through your load. And essentially an H-bridge circuit is what is a DCC booster. You know, it takes the DCC signal, but it then moves it. Now obviously these are completely different size things, so one's gonna have some oomph to it and the other isn't. I think these circuit boards, I mean basically I've got 5 of these for 11 quid and I got 5 of these for 6 quid or something. So this is twice the price of this. I'd love it if this could work, because obviously it's smaller and a bit simpler, but maybe not. So the way all these things, these are intended for is sort of like remote control cars and stuff like that. So it's got it controls 2 motors, you know, sort of one for each wheel or whatever. And then you can do funky stuff with them. Now, let's have a look. What have we got here? It says it's got in1, in2, in3, in4. Out1, out2, out3, out4. So those are the 2 sort of motor connections. The in pins, presumably that's for sort of the controlling signal. And I'm not sure what these 3 are going to be. Oh, it says plus 12 volts, plus 5 volts and ground. Now, do I have to supply the 5 volts and the 12 volts? If I supply the 12 volts, will it generate the 5 volts? Not sure about that. Anyway, let's have a go by, first thing to do, let's just connect up 12 volts to it and see what happens. Right. Oh, yeah. Do you know what? I thought, am I going to need a screwdriver? I thought probably not, but I will. So let me go and get one. So I think these, what did I Google? I298N or N298, something like that. Let me, hold on, let me get the old Google up and let's just have a look at let's change the scene. Desktop. There we go. Right, what are we searching for? i298. There we go. i298 motor driver data sheet. That sounds good, doesn't it? There we go. It's the L298H bridge. So this is the actual chip, which is you can't see very well, can you? But that'll be this actual semiconductor here. And so this one has got a different chip in, so that's something completely different. And actually, yeah, if you look at the block diagram, you can sort of see how it's sort of arranged into an H. You see it's this arrangement of transistors here. Right, so let's have a look. Not sure what's the Right, we've got supply voltage, the logic supply voltage. So logic supply voltage, that's sort of turn it on and on. Input and enable voltage. Don't know about that. Okay. Maybe these are perhaps it's the same chip, but or the same thing, but it's so you've got multi-watt 15, which is this, and then power SO20. How many nodes has this got? 1, 2, 3, 4, 5, 6, 7, 8. One side we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I get the feeling it's not the same thing. There's tiny letters on there that I can't read. Anyway, we'll come on to the smaller one in a minute. Let's just have a look at this first. Enable B, enable A. Right. Okay, well this is all fun. At least I've got a data sheet. I have to see what the chip is on this other one. All right. So we come on to that again in a minute. Motor driver, H bridge. Motor driver Arduino interface. Here you go. So it's used for driving cars. Let's see. That's the thing. All right. Pulse width modulation. There we go. That's what we got. One of those. So looking here, it says so the motor's go on either side. It's got a 5-volt regulator chip on. Yeah, so that's good. Jumper for the regulator. Okay. motor supply. Okay, let's take a closer look, explain how it works. The module has screw terminals, yeah, for the motors. So I might as well just wire that up to my Tortoise in a minute. The VCC for motor and a 5-volt pin, which can either be an input or an output. Okay. This depends on the voltage used at the motor's VCC. The module has got a regulator, which is either enabled or disabled using a jumper. If the motor supply voltage is up to 12 volts, we can enable the 5-volt regulator, and the 5-volt pin can be used as an output, powering the Arduino. But the motor voltage is if the motor voltage is greater than 12 volts, which ours is, we must disconnect the jumper because those voltages will cause damage to the regulator. In that case, the 5-volt pin will be used as an input, and we need to connect it to a 5-volt supply. Okay, so we've got to provide our own supply, basically. We can note that the IC makes a voltage drop of about 2 volts. So if we use 12-volt supply, okay, all right. Enable A, enable B pins are used. So which is enable A, enable B? Ah, right. So there's a jumper. If the jumper's present, the motor will be enabled and work at maximum speed. If we remove the jumper, we can connect a pulse width modulation input to the pin. And in that way, control the speed of the motor. Okay. There we go. I don't know if anyone's keeping up. Quite what's going on. Perhaps you've all gone home. If we connect the pin to ground, the motor will be disabled. Okay. Oh, I see. So there's some jumpers. Oh, you can't see. Let me hold on. Let me change the scene. Right. So there's a couple of jumpers there and there. So that will probably be the jumper for enabling the 5-volt regulator or not. And there's a jumper here either end, which we'll use for deciding whether we're doing pulse width modulation or not. And I think, see, it's a shame. If I had 12 volts, it'd be nice to just give it 12 volts and it's got its own 5-volt supply. Oh dear. Right. What I'm a bit worried about, trying to understand what it is you're trying to achieve. To be honest, Joe, I just want to figure out how this circuit works and how I can use. I want to put something together that I can use to drive the Tortoise point motor using a logic input. You know, so 5 volts up or down, on or off. Because I know then I can use the output of an Arduino to do that. So I'm just trying to sort of develop a Tortoise point motor circuit, driving circuit. Arduino, yeah, blah, blah. Very good. Get the components. Oh, here we go. We got some links. Arduino board. So let's have a look. See what the suggested link. Oh, sorry. Let me show you my desktop again. So what I've done, I'm just having a look at this link here onto Amazon, and there we go. So it's one of these. And what they're selling it for. What's the price? Doesn't say. It's a bit strange. All right. Anyway, we got the. This is the board we're looking for. Right. 5 volts. What I'm worried about is if they need to have a common ground. If I try and supply my own 5 volts, that's fine. Well, let me just give it 12. Hold on. We'll deal with this regulator first. What does it say? Driver. So I assume removing it disables the regulator. So let's do that. So we take a jumper out, and let me just let me take the voltage off for a minute. Where's the hand gears, the screwdrivers? So ground and plus 12 volts. So I will just plug this in. We will see what happens. Oops. So that's 12 volts, so that's the red wire. And this is ground. Right, so if I power it up, let's see what happens. Well, well, the answer is nothing happened. Okay. Looks to me like you could use one board to control 2 Tortoise motors. That's absolutely right. I could use one board to control 2 Tortoise motors using one Arduino, and then you have the challenge of connecting the LocoNet to the Arduino to make it DCC. Well, I don't have to connect LocoNet to the Arduino because I could read the DCC bus. So I don't need LocoNet for this. Yeah, bye Joe. I don't need LocoNet for this. But what LocoNet allows me to do is provide feedback. So what I also want to do is use the same Arduino to then sort of look at the feedback. Right, is this working? And no, it's not. So for some reason we don't have. So what's going on there then? So what's happening here? This is me just plugging, just testing the voltage I'm actually supplying, and it says I'm not supplying any voltage. which is weird because I thought I was supplying some voltage. So why do they not work then? Why do I not have voltage across those two lines? Oh, this is also boring. But actually what I want to do is not just connect one of these to one Arduino. I want to connect lots of these to an Arduino. I only need one Arduino, but I need this to drive two motors. Oh, well, that's ridiculous. Why have I not got a voltage here? Because I haven't plugged it in. I have plugged it in. So this is a dangerous thing to do because this runs the risk of shorting it out. What's happening? Oh, yeah. Nothing. So why do I not have? Why is this power supply stop supplying power? Is it because my dodgy soldering's come undone? Which would sort of ruin everything if that's the case. Okay, might help if these leads are actually plugged in. That'd be a good thing. Okay, so we're up to 17 volts now. Right, so the problem was that the leads on my multimeter weren't connected properly. So now let me test these wires again. So again, 16 volts, so that's good. So plug it back into the circuit. Good. So if I plug it back in there, again, nothing happens in terms of no lights come on. But that is getting 16 volts. Okay, so that's good. So what I might do, I might just for a moment connect up this 5 volt supply and see if anything happens. Oh, okay. Right. So I think the 12 volt supply is there. Because I've taken this jumper off, it's not powering the 5 volt regulator, so there's no 5 volt supply. Now I could also attach my 5 volt adapter. So I've got this here. And because because of the physical design of this plug, it won't plug in next to the other one. But I could plug that in, and then I could use this supply to fire up the 5 volt circuit. Okay. I think I'm going to do that, but I think first I'm going to put different ends on here so it's easier to use. Okay. So this is a chance for me to show you how I like to remove these DuPont connectors. Show you this. Sorry, just messing around a bit with my computer. Right. So there's a little tab here, and you need to sort of get under it somehow. And I like to use just a little piece of wire. So you can sort of get in there, and then put it across the tab like that, and then you can slide this end off. There you go. So that can be reused now. I'll just do the other one. There we go. That comes off too. So these are no good. I don't know if I'm going to have much luck taking these off. I'll probably just need to cut them off. Yeah, I think that's what I need to do. So I'll do one at a time so I can do them in order. So black off first, I'll strip it, and then stick a male DuPont connector on instead. There we go. You just need the tiniest, probably 3 millimeters, something like that, sticking out the end. Let me just unplug that for now. This is what we're looking for. It's in the crimps. There we go. Right. So that's gripping onto the insulation, and the conductor is crimped as well, I think. So it's just enough space on the end of these wires to put a different connector. Yeah, so what I hope is I can control 2 Tortoise motors with each of these boards, and if they cost me like £1 each or something, so that's 50p per output, plus an Arduino. But I can use an Arduino to do loads of them. Put that on sort of the wrong way up. I can twist them around, that's fine. And then if I use a 2x2, yeah, so if I use an Arduino Mega, I think I've worked out that's got a maximum of 70 outputs. And you need 2 outputs per Tortoise, because you've got to be able to say go one way or go the other way or nothing. And so that's 35. And I think cheapest I can get an Arduino Mega is like £12 or something. So the Arduino bit's going to cost £12 for 35, and then I'd need these are costing about £1 per Tortoise. So what's that? That's not very much money. It's like £2, £3 per point. So that would work quite nicely, I think. There we go. I can just see which is red and which isn't. So we can have the red at the top. There we go. Right. So that's my 5-volt supply, my 12-volt supply. 5, 12. Now the problem is I need to get rid of this and get one that's got more sockets. By magic I've got a 4-way available. So this will go here. Okay, so that's hooked up 12 volts and 5 volts. Now, the big question is, can I join these 2 grounds together? And I think what I'll do is I'll just try and see what happens. I think the answer is yes, I can, because I've got 2 independent power supplies. However, when it comes to, let's just try it. There we go. When it comes to my layout, I've got a 5-volt bus and a 12-volt bus running around my layout, but I can't join the grounds together, because that's where the grounds is where the meters that monitor them are, so they're not equivalent. So that's annoying. I'm going to have to possibly revisit that. Anyway, let's so here we go. Here's a ground. So I should be able to let me just stick a red wire in both the buses, and then I'll measure some voltages across them. So I should be able to get 5 volts and 16 volts and 11 volts if they've got the same ground. Is that right? Will that work? Anyway, I'll give it a go. I see the problem. Right, I haven't joined up the buses across the top, so I will do that now. That's the point at which everything might blow up. My black wire. Right. It's the multimeter saying it wants some attention. It wants to be used for something. So this is all just stuff I only have to do once I get my breadboard going. I'll be a bit happier. Right. So the world may blow up at this point. I'll find out. No, nothing's happened. Those are still there. Alright, I think we're doing alright now. So let me, come on then, you can be used for something. Can you see that? Yeah, some voltage. So if I've got a common ground there, hopefully. So if I measure that, that should be 16 volts, it is. If I measure that, can you see? If I measure that, that should be 5 volts, it is. If I measure between these two, it's 11 volts, which is the voltage difference between the two. So that's sort of what I expected, so that's great. Okay. So now what I can do is feed this 5 volt supply into the module. So we're starting to get there now. We're starting to do some stuff, which is making me happy. So if I take this 5 volts, this can go into here. So actually on the layout, I can, what can I do? On the layout, I could use one of these to generate 5 volts and use that to feed the Arduino. And then I could feed that same 5 volts back to all the others. Yeah, that might work. Right, let me plug this in. So I should get a light come on because I've got a 5 volt supply going into it now. Ta-da! That's fantastic. Okay. Oh, that's good. That's good. Right. So I think I can now. I've still got this voltage. This voltage bridge bit of the circuit. So what I could do is myself a longer green wire. And I can connect that to the logic input. So that's good. So then I've got a sort of logic. Let's have a grey wire. So grey is my sort of logic input. Maybe what I want to do is just read the instructions again. You put that over there. Let's have another look at the instructions. All right, that's all great. Next are the logic control inputs. The enable A and enable B pins are used for enabling and controlling the speed of the motor. If a jumper is present on this pin, and I think it's just going to show us what they. It's all sort of how to make a car, isn't it? Enable A and enable B. E and B, E and A, I think it says in there. Let me turn this off again. There we go. Right. So I think, looking really carefully, I can see that says NA, ENA, and that says ENB. So those jumpers are enable A and enable B. Right. And if just looking here on the instructions there, enable A, enable B. Mine is slightly different, doesn't have that text on, but don't worry about that. Okay. If a jumper is present on the enable pin, the motor will be enabled and work at maximum speed. Okay, and the jumper is on, so that's good. And if we remove the jumper, we can connect a pulse width modulation input to this pin, and that way control the speed of the motor. If we connect this pin to a ground, the motor will be disabled. Okay. The input 1 and input 2 pins, which are the ones next to it, are used for controlling the rotation direction of motor A, and 3 and 4 motor B. These pins we actually control the switches of the H bridge. Okay, all right, I get it. Inside, if input 1 is low and input 2 is high, it goes forward. If input 1 is high and input 2 is low, it goes backwards. In both cases, inputs are the same, either low or high, the way it will stop, the same applies. Okay. All right. Okay. Okay, I get it. So I need something I can slip on to those two, don't I? So actually I need 2 wires. So I've got a grey one. What other colour have I got? Green somewhere. Oh. Right. Got a green one as well. So I like these solid core wires because they fit into the breadboard nicely. But if I put some female 2-point connectors on the end of here, it'll work. Okay. Gonna run out of these. I have to get some more 2-point connectors. I bought that kit, which is a good way to start, but actually I use particular bits in it more than others, so I'm going to have to change that around. Let me give you a different scene. There we go, not me so much. There we go, a bit more what's going on. Right. Just put these bits of wire on. I've been going for a while now. I've been going for an hour and a half or so, so I think this might be sort of perhaps the last bit of it. If I can get this going. We give ourselves another 2 side-by-side housing. Mount them in. So what I'm thinking, I can put these side by side, and then I can plug them in to the 5-volt bus, one way round or the other, and that should work as a sort of logic input. Let's say the female ones are really much harder to get in. So let me try this. Just push that in. Straighten this out. So I should be able to pop that on there. Okay. And then I can do things with this. I think what I'll do then is I will... This is just so I can sort of plug it in and take it out easily. I'll put male connectors on here. I can plug it into the bus one way around or the other. That's one. Here comes the next one. It used to take me forever to do these, and I think I've got pretty slick at it now. There you go. Another 2x2. You can see I'm going to run out of 2x2 soon because I use them all the time. It's kind of obvious. It's going to be the most used one. Right. So now I can plug these into the 5-volt bus one way around or the other, and that should then enable the output one way or the other. So let me plug it in now. So at the moment there's nothing on either of those inputs. The question is, what is the output voltage? Can you see? Okay. So that says 200 millivolts. I'd rather it was 0, but there you go. 200 millivolts. All right. Now if I plug it in one way, so I'm giving it a logic signal. So I'm doing red at the top. Let me make sure I measure it the same way around both times. There I get -15. And if I plug it in the other way, red at the top, I get +15, which is exactly what I anticipated. That's what I wanted to happen. So I can now wire in this Tortoise motor and plug it into here, and I should be able to control it by doing this. So let me do that, because that will sort of get us to a nice sort of point of completion. Now I use blue and yellow for my Tortoise point motors. So There's a big bag of colourful cables. There I've got some yellow. There's some more yellow. Is it the same yellow? Not sure. Whichever. So there I've got yellow. Here I've got blue. That's blue. I think what I'm going to do, I'm going to just solder on one end. So we've got to plug in the soldering iron. Let's get the soldering iron going. Fun, fun. Whew. Right, sort of managed to make some progress on this. I was getting a bit bogged down, but there we go. We're up and running there. So that doesn't need to be too long. There's the blue wire. And here is the yellow wire. I know there's still a whole bunch of people watching. I think there's 5 of you watching, but you're all a bit quiet at the moment. You're very welcome to say hello. Give me a bit of encouragement. I know streams that generally people are a bit chattier at first because they, you know, but then my energy starts to flag. I get tired, and people sort of talk to each other, and then go and do something else. So that's fine, but. There we go. So if I strip these off, so I'll solder it in and then screw it in the other end, and then we'll see where we are. One of the tricks I've learned with these Tortoise point motors is to drill extra holes in these tabs, because often you want to put more than one, have more than one connection to a tab. So they make quite a good sort of soldering spot. There we go. Right. Are we up to temperature yet? No, not really. It's a bit longer to start. There's also a problem with this in that the grub screw has come loose, and actually the whole tip's a bit loose. So maybe there we go. So tighten it up. There we go. Get a bit of temperature there. Yeah, I sort of damaged the grub screw on that, so I need to replace it before it completely shears off, and then the whole soldering iron will be in the bin. But having said that, it's not a great soldering iron. You know, it's sort of cheap as chips. So, is it getting hot? It probably is. I think it's getting hot. No, it's not, because it's not plugged in. Oh dear, oh dear. What a wally I am. There we go. Plug in the power. It's on the same power strip as the power supplies. So this is quite fun then. I can use 5-volt supply to I can use the 5-volt supply to sort of power to control the higher voltage supply, hopefully the 12-volt supply, to drive the Tortoise point motor. So having got this sorted, it's then a matter of connecting up to getting the Arduino out. We'll see what we can do with the Arduino. But it's just good to know that I can sort of, the output side of it works. Yeah, we're getting hot now. There we go. Melting solder. That's a nice connection. And I'll just try the other one as well. See, I can clean that in my, you can't see, can you? Okay, just clean the end by dipping it in the brass sponge. Put the blue one in as well. That's good. Right, so those are both in. Just turn it off first before it starts doing things. I'll unplug the logic connection. Where's my screwdriver? Put this on here, open these up. Screw these in. Let's go the other way. Okay. So I think we're good to go now. So just check all my other connections are right. Okay. So let me turn this on. I'll give it some power. And nothing happens. Why would anything happen? What's happened here? My common has been pulled out. Whoops. All right. My ground connection on the supply voltages has come out. Okay, that's good. Right, let me plug it in again. Right, now can you see everything? You can see the end of the Arduino there, the Tortoise point motor. So if I connect up the 5-volt supply one way, and it moves and it stops because it stalls. And if I turn it around the other way, what about that? So all I got to do now, is plug this into the Arduino, write an Arduino sketch, is it called? But anyway, a script, a bit of software that will set these logical outputs appropriately, by connecting up to digital output pins, and then I can drive this left and right. That's a good thumpingly confident movement. We're not mucking about there, are we? Although that we are giving it 15 volts rather than 12. But it likes that. I need to get like a little 12 volt voltage regulator just to regulate that. But that is great. I like that a lot. And then I'll need an interface. No, you're quite right. And then I need an interface so that the Arduino can read the DCC bus or read the LocoNet bus. I could do it either way, I suppose, but I want it to be able to read the DCC bus. So I don't think I really need any more than this for my to drive Tortoise point motors. I mean, that's it. So each one of these can do 2 board Tortoise point motors. There we go. Now the question is, can I do the same with this little fella? And I probably can if I can supply it with 10 volts. Oh, so what's it got? It says plus minus, so that'll be the power. I'm going to have to try and read up what this is. I'd much rather do it with these because they're smaller. So that's just that's better, isn't it? And they're cheaper, so that's better too. Cheaper's better. So I could solder in pins so I can connect it up. But anyway, either way, I think we're doing pretty good. I love this. This is great. Yeah. There we go. That's what. No, it's all right. Limo station. I know. I understand what you're saying. You know, I need to interface it to DCC bus, and I also want to interface it to LocoNet bus, which is this thing that I haven't got going yet. But we'll get onto that in due course. So no, I understand I need to do that, and I will look at that website because I think that'll be really useful. So yeah, don't worry. I hear what you're saying. It's several different components that I need. You know, there's basically interfacing an Arduino to DCC bus. There's interfacing an Arduino to LocoNet bus. All right, so I need to work out how to do both of those. And I've then got logical inputs and functional outputs to the Arduino. So this is one of the outputs, which is driving Tortoise point motor. Another bit is going to be using these other connectors here to provide logical input to the Arduino to tell me whether this has moved or not, and that'll be useful. You've tried the part from Luca. You couldn't get it to work. Right, so you've tried this for the LocoNet connector and you couldn't get it to work. Okay. Well, I know other people have got this to work. So I'm going to give it a go. But I say at the moment I'm just pulling together various different bits that I'm going to need to make up different systems. So there's loads of stuff I want to do. I want to do block detection, and for that I've got to work out how to build a sort of current sensing device. I've got to do James Pett, lovely to see you. James, I'll tell you what we're up to in a minute, because I was just about to sort of turn off, but I'll tell you what we've been doing. But yeah, I've got to do block detection, so I've got to do current. I want to do detecting the position of my Tortoise point motors. I want to drive the Tortoise point motors. And what else have I got to do? And then I want to be able to send commands over the LocoNet, so I can say switch this point, switch that point. Yeah, I know you approve of block detection, James. And I want to be able to also read the commands, switch the point, so I can build control panels and mimic panels. So yeah, there's a whole bunch of different stuff I want to be able to do, and I'm just working out what the basic circuits are. So James, what I've been doing, I've just bought some electronics and I'm mucking around, but I'm using one of these motor controllers. It's just like an H-bridge circuit to control a Tortoise point motor. So I mean, I've plugged it into, well, it's supposed to be a 12-volt supply, but it's actually near a 16. So that's the motor driving voltage, and then across the top here on my breadboard I got a 5-volt supply. So this is the sort of 5-volt logical input, and where we've got to is I can plug it in one way and the Tortoise point motor moves, and then plug it the other way, it goes back. So that's giving 16, well, probably near 14 volts to drive the point motor, but controlling it using a 5-volt supply, a 5-volt logical supply. And then the next thing is getting an Arduino going. I've got an Arduino here. So here's my Arduino. I'll tell you what, I did say in this stream that I'd open the Arduino, so let's open it and have a look. Whoops. And I'm going to do it, yeah, James. So I'm going to do it by iTrain. So what I want to do is, I got some of these circuit boards manufactured in China. You can get these made up, and then I've soldered some components on. In theory, I can use this to connect the Arduino to the LocoNet bus, and then I can have an Arduino putting commands on LocoNet to say, change the points, or detecting what the commands are being sent, or whatever. I mean, there's loads of stuff you can do. No, and it's all with iTrain. But the point is, James, I can build a control panel where I can press a button on the control panel to change some points, and instead of changing the points, it sends a LocoNet message via this, message on the LocoNet bus, and then iTrain picks that up, so that it keeps iTrain's state consistent. So the point will change on the screen, but also I assume iTrain will then send out that command on the DCC bus, and the actual point motor changes. Oh, there's an easier way of doing that. What's that? Go on, what's the easier way? I just need LocoNet IO modules. You use them at home. Okay, very good. So what's a LocoNet IO module, James? Look for Hans Deloof. Right. Come on, we're going to do this now. Amazing. James Petts turns up, and within a couple of minutes, he's told me that everything I've been doing doesn't need to be done. So what did you say? LocoNet IO module is a module that allows logical states to be read and written from LocoNet commands. Yeah. Well, that's what I was going to use the Arduino for. You're saying there's something I can buy that already does it? So I kind of like the idea of just being able to write my own software to run on the Arduino and just do funky stuff. LocoIO. The LocoIO module for LocoNet. Is that what I want, James? I can buy it as part of a kit. Oh wow, okay. Search for, okay. So Hans Defloff. About Hans Defloff. Is this what I want? No, you've already found it. Okay. Is this the guy? He's an associate professor. Gosh. All right. Anyway, you're saying this is what I want. So is this a board that I can buy, or do I need to get it made, or what? How does this work? Oh, I can order at the LocoHD web shop. Yeah, no, don't worry. I'm sure there's a lag. Okay. I can purchase one for €42. Doesn't sound so great. So what's it got on it then? It's got 2 LocoNet connections. And 1, 2, 3, 4, 5, 6, 7, 8, 9. So what's that? 10 maybe. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 18, maybe 8, so 16 connections. Right. Well, in theory, I could get myself I use loads of these on my layout, signals and input buttons. Right, okay. I'm not sure that it's him, but these are the modules. Get the screw turner ones. Well, what I was going to do was get an Arduino Mega, for example, which has got 70 logical inputs or outputs, and I can get one of those for about 10 quid. No, let's say more, 12 quid. I can have one of these things. Let me change the things. You can see what I'm waving in front of you. I can have one of these things, which cost me 40p for the circuit board, and sort of like a pound for the components. So £2. 70, you'll have wires everywhere. Yeah, well, that's the point. Be a big thing, but I can stick them all in anyway. So that gives me 70 inputs or outputs, whatever. 1 LocoNet connection. And then for example, I could build a panel, and obviously there's, each button or each LED needs to have wires going to or from somewhere, and then connected to this, and that's all in the box. So then when I actually use it, I just have one LocoNet connection going into the box. If all your local wiring goes to a central point, you lose the benefit of data bus wiring. You don't need any of that stuff, right? You're all telling me I'm wrong. Okay, go on. Anyway, you can do more sophisticated things with an Arduino if you've already done all the work there. Right, okay. Well, I haven't done all the work. I literally just opened the packet for this. and I've never worked with an Arduino before, but you know I can. So let me see if is this barrel plug, does that work? Yeah, that's nice. So that's good. So I can power this using one of these plugs, so that's good. If I need to, it's got a button on, whatever the button does, who knows. So yeah, anyway, this is all just me learning stuff. So, but I know there's more than one way to skin a cat. Definitely have distributed models with a few inputs rather than one huge model with all the inputs. Yeah, no, I think you're right. You're right about that. But even with let's say I've got 70 inputs or outputs, so I need 2 outputs to drive a tortoise. Yeah, I need 1 input to give me the position of a tortoise. So that's 3 digital thingies per point. So what's 70 divided by 3? Well, let's say it was 60. So that would allow me to deal with 20 points. Well, if I got like a big yard, then with 20 points on, then I could sort of have one of these and all that, you know, with my 20 points, and it would all be vaguely up together. Anyway, I'll give myself lots of options. What's that? Anyway, but that's what we're doing, James. It's good to see you. I'll be honest, I'm really tired. I'm going to go to bed now. If I have one I/O device with 70 inputs, you'll have to run all 70 sets of wires back to a single point. Yeah, no, I get that. I get that. But what I'm saying is, all you need is a Mega, yeah, and a connecting prototyping board. Yeah. There's much to be said for going to bed. Yeah, well, I think you're right. Anyway, let me just excitedly whiz this round again. Oh, look at that! Look at that! Look at that! It moves left and right. Nice to have achieved something. Anyway, I've had a lot of fun. Look, it's great to have people's company, and you know, particularly pleased to see you all. It works. It works. That's great. Anyway, so I've got a lot going on in my life. James, I don't know if you picked up. I'm moving house in a couple of months, so I've got to pack everything up, and so I don't really know. I'm not going to be able to produce much video, I don't think. I've got a video almost ready to go. I hope to have it out next week on Friday. You don't envy me. No, I don't. The trouble is, James, my house, it's like a tied house with my job. So when I changed my job, I had to change the house. Thanks, mate. Thanks for the best wishes. Anyway, the point is, yeah, I'm changing jobs, so I'm changing house. But what I'm going to do is I'm going to put the new house in in a new house. I'm going to get a shipping container and put everything inside a shipping container. So that will that means that the next time I move house, then I can just take the shipping container with me, and I'm gonna insulate it, line it, make it all nice, and yeah, then I've basically got a portable room. And the good thing is I'll have more square footage. Sheds are better than shipping containers. Is that what you're saying? Sheds are... Go on, explain that. Why is a shed better than a shipping container? I'd be interested to know. I'm waiting, James. I'm just waiting. Let me put this over here so it looks like I'm looking at the camera, but I'm actually looking at what you're saying. Yes, a shed can have air conditioning, good electrical supply, good insulation, and be bigger. It could be bigger, but it could be smaller. But a shipping container can also have air conditioning, good electrical supply, and good insulation. Well, it depends what you build inside the shipping container, doesn't it? I mean, so what I'm going to do is I'm going to build like a stick frame on the inside. So I'll insulate it with Celotex. I see the benefits of portability of the whole thing. That's a cunning plan. Yeah. But I'll insulate it with Celotex, and put some rock wool in the roof. Well, at the moment my layout is portable, but the problem is, you've got to have a room the right shape and size. And as soon as you make a layout that's sort of a bit longer than the room suddenly you find you can't have it, And I just really don't want to be restarting when I move house. I'm interested to see how you get on with the shipping container thing. It's a cunning plan. Yeah, no, I think I'll be all right, and I can run, I can run electric out to it, there we go. Restarting's not ideal. Anyway, James, what happened at Worley? What's the best thing at Worley? Tell you what, let me just unplug this. Oh, I have to tidy everything up in a minute. I was thinking of going to Worley, but next year I'll be living a lot closer to Worley, so I'll go then. Hope you film the shipping container. Would make for interesting set of videos. Yeah, no, I'm sure. I mean, I'll film whatever I do, What happened at Worley? There was a model rail exhibition. There were lots of layouts and trade stands. Awesome. No, I will go. I want to go, but well, anyway, I'll go next year. I've got a lot on at the moment. Was it good for Engage though, James? Hey, good night, Lawway Station. Thanks for being in. I've got to say, and thanks for your advice on that website. I'm definitely going to look that up, because that sounds like just what I need. Right, I'm going to bed. James, it's great to see you. I'd love to meet you one day. I'm sure it'll happen. Maybe another time at Worley or somewhere else. Yeah, I did go to Tins this year, but only for the first time. I had my other half's son with me, who's young and excitable, and to be honest, not the best company if you're gonna seriously go to an exhibition. So there we go. Right. Anyway, thanks for the move. Good to chat, and I'll see you again. All right. Okay. Good night then.